Oh, and by the way, Dr. Novella has a day job, too. It turns out that being a famous podcast host and an author is just his side gig. He's a medical doctor, an academic clinical neurologist, a researcher and assistant professor of neurology at Yale University School of Medicine. So he's got quite a career. So tonight, speaking about countering creationist logic, is physician, blogger, podcaster, and a skeptic of some note, Dr. Stephen Novella.
Well, thank you all so much for having me here. Thanks to the Darwin Day Committee for inviting me to come to Tyler, Texas. My first time here, but everyone has been great. We have a lovely town. So I'm going to talk about actually one of my favorite topics to talk about in science and critical thinking. This is the one that got me into the whole science communication thing in the first place. I've been a big fan of Darwin and evolutionary theory since I was a young child, and it was amazing to me. I couldn't wrap my head around this idea that there were people who didn't believe in evolution, that they, how could you have any familiarity? I at the time thought, with the mountain of evidence in support of it and deny it. So I assumed, like most people going into this kind of thing, that they just didn't know the facts, right? They were just ignorant of the information, and that was pretty much the only explanation necessary for why people, rejected a mainstream, pretty much well-established scientific theory. Turns out it's a lot more complicated than that. We've learned that over the last, few decades, myself personally, but also I think just scientists in general. For those of you who aren't familiar with my work, my podcast, my book, so I'm a science communicator, but in a very specific tradition we call scientific skepticism, a term first popularized by Carl Sagan. And what that basically means is that we teach science and critical thinking at the same time, kind of as two sides to the same coin. And a lot of that involves addressing pseudoscience, right? So we want to understand pseudoscience as a phenomenon and be able to address it directly. So with that, I'm going to talk about creationism, creationist logic, and the kinds of arguments they use to maintain what is really evolution denial. Start with a quote from Ken Ham. Ken Ham is a famous young Earth creationist who wrote, "But those who promote Charles Darwin Day are really promoting an anti-God religion. The evolutionary worldview is an attempt to explain the universe and life without God." That sentence is actually correct. That is true. That is what we're trying to do. It's a religion of naturalism and atheism. That part is not true. So, science is not a religion. Often those who are trying to promote an anti-science agenda will make that argument. It's based upon a philosophy, the philosophy of actually what we call methodological naturalism. He left that word out, and that's a very critical word. It's as opposed to philosophical naturalism, which is what he's talking about. What that essentially means is, if you're doing science, you can't introduce magic, right? You can't basically say, and then a miracle happens. You have to do the math, and it's got to work all the way through. Every physical cause has a physical effect, etc. And there's a reason for that. It's not because we're unfairly excluding the supernatural or the paranormal, which is what some creationists or proponents claim. It's because science cannot work if you introduce magic, right? It simply does not work. So the rules of science require that any idea that you put forward has to be falsifiable. There has to be a way to prove it wrong. So if you can't prove your ideas wrong, they're not scientific. You failed step one in doing science. That's it. So that's why that middle sentence is correct. It is an attempt to understand, to explain the universe within the rules of science. Now, this also means that science is agnostic towards any claim that is outside of the realm of science. It's actually not atheistic, right? It's not a religion because it doesn't hold any a priori beliefs. It says, well, here's a set of rules that make logical, philosophical sense that we're going to follow in order to build an empirical, testable model of reality. That's all it is. We don't make any claims about anything else, and science is officially agnostic towards anyone's personal belief that is metaphysical or supernatural. But what that means is if you're making a scientific claim, you've got to play by the rules of science. And so what I'm going to be talking about tonight is not anyone's faith or personal belief. It's creationists playing by doing science, but getting the rules of science wrong, right? They're breaking the rules of science. They entered into the arena of science, but then they do it wrong. Okay, so first there are some different types of creationism. It's actually a fairly broad term. A young earth creationist is someone who believes that the world is 6,000 years old or 10,000 years old or something like that, based upon a literal interpretation of the Bible or some other holy text. And that they don't believe in evolution. They also don't believe in an old universe or an old earth. The day, age, or old earth creationism accepts that, the earth is 4 billion years old, but evolution still didn't happen, right? Or they limit evolution in significant ways. Progressive creationism is an attempt to basically acknowledge a lot of evolution, but reserve a role for God, right? So that's what we call a God of the gaps kind of argument. And they actually coined the term microevolution. You may hear that term microevolution versus macroevolution. That's not a scientific term. Scientists don't talk, because there's no actual distinction between those two things. It's an artificial distinction that the progressive creationists invented in order to say, okay, we'll acknowledge all that evidence for microevolution, but it still can't account for the origin of all life, so that's where God got involved. And then most recently, there's this movement called intelligent design, which is a deliberate attempt to recast creationist arguments in scientific jargon. But it isn't a science because it suffers from all of the same problems that creationism does, creationism as a science does, in that it's not falsifiable. Again, it misses sort of that first criterion. And I'll talk a little bit specifically about some of their core claims. But what all of these things have in common, wherever you fall along the spectrum, from a young earth creationist to just reserving a sliver of holdout for God's hand in things, is to some degree you are denying the scientific consensus on evolution, right? So you are denying the science. All right. Now, if you're denying evolution, we have to talk about what do we mean by that? What is evolution? So there's several large claims made within the rubric of evolutionary theory, right? So when we say you're denying evolution, people deny different aspects of evolution. The core aspect is common descent. That just means that all living things are related to each other, right? We're all related to each other through a nestled hierarchy of common descent, just like you're related to your siblings and to your parents and to your cousins and then your second cousins and to pretty much you're related to every other human being on the planet. So the only question is how far back do you have to go before you find your common ancestor? And the same is not only true of every human, it's true of different species and then all the way up to all life on Earth. That's that's Darwin's hand drawing that he made in Origin of Species, showing this branching relationship of all life. Common descent, just that basic fact that all life is related to all other life through this kind of branching descent, that's the part of evolutionary theory that is established beyond all doubt, right? There's no legitimate doubt about that among scientists. Like pretty much every working scientist who's involved with biology, development biology, evolution, whatever, accepts that. I think the literal figure for just all scientists is greater than 98%, because some scientists are fundamentalist Christians or whatever as well. But there really is no controversy about that, and the evidence is absolutely overwhelming. However, there's another part of evolutionary theory, and this is actually the part that Darwin came up with, and that was natural selection, the mechanism. What's the primary driving mechanism? How does evolution happen? How does it work? Natural selection basically means, there's natural variation among individuals within populations, within species, within groups, and selective forces are acting upon that variation. Those that are better adapted for their local environment have a greater statistical chance of surviving, and that's pretty much it. It's just those genes which give properties which make somebody more likely to survive and have kids and raise those kids are more likely to be represented in the next generation. That's it. Natural selection is actually not the only mechanism of evolution, and there's legitimate debate about how important other mechanisms are, like genetic drift and just recombination and mutation, and how much change happens as a consequence of those things without selective pressures. So, evolutionary biologists will argue about exactly what the balance of those forces are. But that natural selection is happening, also not controversial. And then there's this, what we call the phylogenetic, that just means the evolutionary history. So that's like what evolved into what when, so exactly how do we draw the branching relationship, like what's the closest common ancestor that humans have with other apes and so on. And that is a moving target. That changes every time we find a new fossil, right? Obviously it doesn't completely change. It's like filling in a puzzle piece. The pieces that you have may be correct, and you may be able to say some things that are true. Like our closest relative are the other great apes. It's not going to be horses tomorrow, right? We're not going to find a fossil. No, we actually evolved from giraffes, right? That's not going to happen. But which, exactly what pathway and which of the species that we found are on the more of the direct path versus a side. But those things change all the time as we find new fossils. But again, that doesn't call into question the deeper reality of common descent, right? This is just the details about exactly what evolved from what. Creationists will, however, exploit legitimate lack of knowledge and disagreement and argument about the details as if it calls into question the higher level, the higher order basic fact of common descent. All right, so there are a few common intellectual features that creationists tend to use when they are making their case. So first of all, creationism is a campaign of science denial. They don't have a positive alternate hypothesis or theory to put forward. They essentially set up a false dichotomy, and that's what Ken Ham was doing in my opening quote. Either you believe in God or you believe in Darwin, right? They want to make it about the guy, about Darwin as a man. And they want to make it a culture war, right? You're either on our side, you're on Team A, or you're on Team B. That they want to frame it that way because they lose the science fight, right? They don't win in the arena of science. They want to make it a culture war. They want to make it about you either believe in Jesus or you believe in Darwin. It's not what it is about. But what they don't have is despite all of the hand-waving of the intelligent design proponents, what they don't have is an actual scientific theory to put up against evolution, because there isn't one, right? So what they do is they just cast doubt upon evolution and then assume that creation wins by default because it's the only other choice, which it actually isn't, but that's how they frame it up, as this false dichotomy. Creationists actually do not understand evolutionary theory. This is a conclusion I've come to after literally 40 years of debating creationists. They simply do not understand evolutionary theory, and I'll give very specific examples of that. They may understand it superficially, but they generally misunderstand it, and they misunderstand it in ways that reflect their creationist worldview. And again, I'll give you specific examples of that. That's the next point. They try to apply creationist logic to evolutionary theory, and then they say, and that doesn't make any sense, which they think implies that evolutionary theory doesn't make sense. Like, nope, it's just what doesn't make sense is your attempt to apply the wrong logic to a scientific, like basically non-scientific logic to a scientific theory. And they are intellectually dishonest. Now, what do I mean by that? They will, I think the hallmark of intellectual dishonesty is if you make an argument, it's proven to you that that argument is wrong, and you keep making it. You don't correct your argument. You don't correct facts when you're told those facts are incorrect. When your logic is shown to be invalid, you continue to use it. Right? Generally speaking, they are starting from a conclusion and working backwards. They're not trying to find out if evolution is true or how life on Earth came about. They have their narrative, and they're trying to show that that's correct. And again, they don't have a coherent theory to put forward, so their entire endeavor is just to try to poke holes in evolution. And so in order to do that, so if your goal is to make a case which is wrong, you pretty much have no choice but to either distort the facts or use bad logic. Because you cannot, if an argument starts with premises that are true and uses logic that is valid, the conclusion must be correct, right? So if your conclusion is wrong, one of those two things has to be wrong. Your logic has to be wrong, or your facts have to be wrong. And so we could always find the incorrect facts or logic in their arguments. Okay, so let's go through some arguments, and we'll illustrate all of these points with some direct quotes from creationists. So one strategy that creationists use, what I call the one fell swoop, right? They're trying to disprove evolution with one piece of evidence. So they're trying to argue in some cases that evolution is literally impossible. And if you can prove that, if you can literally prove that evolution is impossible, then all the evidence doesn't matter. It doesn't matter how many fossils you have. It doesn't matter what the genetics say. You can ignore. You don't have to get deep into the weeds on developmental biology. None of it matters because evolution is literally impossible. So that's a home run for them. So they will not give up those arguments. When they think they have an argument that proves evolution impossible, you will never get them to give it up. So here's my favorite example. So this is a quote from a creationist website about the second law of thermodynamics. Who knows what the second law of thermodynamics is? All right, don't worry, I'll explain it to you. So they say, however, this basic law of science, the second law of thermodynamics, reveals the exact opposite. In the long run, complex ordered arrangements actually tend to become simpler and more disorderly over time. Evolution, with its ever-increasing order and complexity, appears impossible in the natural world. Again, they're arguing that evolution is impossible. So the second law of thermodynamics essentially states that all closed systems tend towards higher entropy, which is another sort of way of saying greater disorder. And since the universe, the laws of physics say the universe must be tending towards greater disorder, and evolution is a process of greater order and organization and complexity, etc., it runs contrary to the laws of physics. It's literally impossible for evolution to happen. But there's a glaring error in their logic, as there always is, right? The second law of thermodynamics only applies to closed systems. The Earth and the biosphere of the Earth is very much an open system, right? It's receiving an incredible amount of energy from the sun. And another law, the laws of thermodynamics state that you can use energy to reduce your entropy. That's fine. You can reduce entropy, right? You ever clean your room? You've reduced the entropy in your room. You have to expend energy to do that. And life expends energy to do what? To grow, to reproduce, to reduce their own entropy. You are all reducing your own entropy right now, right? That's what living things do. Eventually that process will stop, right? And then we die, and then we totally dissolve into entropy. But in the meantime, we can use energy to reduce our entropy. So an acorn growing into an oak tree is a massive decrease in entropy. And how does it accomplish that feat that creationists say it violates the laws of thermodynamics? By using energy from the sun. That's it. It's as simple as that. If you use energy from the sun, you can reduce your entropy, and collectively, over billions of years, the living things reduce their collective entropy by evolving. It's just one of the things that life does with the energy it has. Simple. So that completely destroys the second law of thermodynamics argument. So do they stop there? Of course not. They're not going to give up a good argument, whether it's true or not. So this is what they say. They say, okay, well, the Earth may not be a closed system, but the universe is a closed system. And the universe, we were told by scientists, right, started as an almost uniform, blob of hydrogen gas, mostly hydrogen, a little bit of helium, tiny bit of lithium, right, but it's mostly hydrogen. And a creationist, Dwayne Gish, who was a really gifted debater. I have to give it, he has since passed away, but he made a career debating scientists and winning, not because he was right, but because he was really good at debating. And one of the things that he said was that hydrogen gas is a colorless, odorless gas that when given enough time will turn into people. Right? And it sounds ridiculous, and that's the point. You wanted to make it sound ridiculous. It's like, yeah, that's true. It's literally true. Hydrogen will turn into people, or something like people. It doesn't have to be people. Something complex if given enough time, 13 billion years. But there's a lot of steps in that process, right? That's not a straightforward process. There's a lot of complex steps happening along the way. But how could the universe go from low entropy to high entropy, starting out with just randomness and ending up with complicated forms? It's like, well, that's not what's happening, right? Again, the answer is because you don't understand how science works. The universe is decreasing its entropy. The universe is constantly it's increasing. The entropy in the universe is increasing, and usable energy in the universe is decreasing. That is happening. In fact, if the universe doesn't collapse in on itself, or there's no big rip or something, if the universe just keeps expanding the way it is, the end of the universe will be what scientists call the heat death of the universe, where there's no longer any usable energy to do stuff, right? So nothing can happen anymore because it's just a uniform distribution of heat, the heat death of the universe. That is happening. So how is it possible that that entropy disorder, chaos in the universe is increasing and energy is going away, but evolution is happening? Well, there's nothing in thermodynamics that says that it has to be uniform, right? Entropy doesn't have to be uniformly increasing throughout the universe. You can have a local decrease in entropy as long as it's offset by a greater increase in entropy somewhere else. So the sun is massively increasing its entropy because it's burning through its energy and spewing that energy out into the universe, and a tiny little bit of it is hitting the Earth, and we're using that to reverse our entropy a little bit. But the net entropy is increasing. So again, the thermodynamics are all fine. There's no thermodynamic argument against evolution. So then what do? They go, oh, I guess we were wrong? No, of course not, because that's not what they do. So this is the answer. If you dig down to this level, this is the answer you get to. The open systems argument does not help evolution. Raw energy, whatever that is, cannot generate the specified complex information in living things. So they say you already have to be alive in order to use energy to reduce your entropy. It's like, okay, well, evolution is something that happens with living things. Right? That's what evolution is. Don't confuse evolution with the origin of life. That's two totally different things. The transition from chemical processes to living processes. But they're trying to say, and some of them will even say ridiculous things like, if you go out into the sun, you don't reduce your entropy. You just get a sunburn, right? Things just bake in the sun. It's like, I refer you again to the oak tree, right? Some things use energy to reduce their entropy, and we eat those things, right? We either eat the plants or we eat other things, right? Remember back in grade school about producers and consumers, So yeah, life uses energy to increase its complexity and reduce its... so this is a complete non sequitur. This has nothing to do with thermodynamics. Nothing to do with thermodynamics. Okay. This is another one. This is one of those, like, the first couple of times I heard this argument, my jaw dropped. And I had to really wrap my head around it. Again, I was like, okay, creationists say there's no transitional fossils. There are no transitional fossils. So here's a quote again from creation.org. Transitional fossils are the remains of those creatures which should be found in between one kind of creature and another kind. Again, the kind thing is a creationist notion. For example, evolutionists have long sought the missing link between ape and human, some sort of half-human, half-ape intermediate form. None has ever been found, though many candidates have come and gone. So that's a very specific factual claim. There are no transitional fossils. Specifically, there's no transitional fossils between humans and our ape common ancestor. Yes, there are. And again, you would think that that's all you have to do. Is that, well, clearly you don't know, you're not familiar with the evidence, so let's run through the dozens of transitional human hominid species that have been discovered and continue to be discovered. Pretty much every year or two, another major find comes out. We add another little branch to this, this complicated bush. So you would think that's it. The argument's over. They said there are no transitional fossils. This is a factual claim. There are clearly transitional fossils. A lot of these things are exactly what they said should be. They're half human, half ape, right? I mean, if you do, I think Homo habilis is probably the one that's like right in the middle, and they had a hard time, should we call it Homo or Australopithecus? It's kind of right on that borderline. It's literally, statistically, the brain is halfway in between. Everything is kind of halfway in between, right? It's half human, half ape. It doesn't get better than that. But of course, it's everything in between on both ends and branching out to either side. You know, it's really overwhelming. So what do they say? Do they say, oh, we were wrong? Right? No, of course they don't say that. They just redefine what a transitional fossil means. That's how they get out of it. So how do they do that? They say, well, you can't prove that Homo habilis or whatever you're going to call them is halfway between humans and apes. That's just another kind of creature. But you can't prove that it actually evolved into humans. It's like, well, now that's a different criteria that you're just throwing in there. That's a way of moving the goalpost, right? Say, well, it should be halfway in between. Here's something halfway in between. Okay, now prove that it was actually on the line to becoming people. It's like, well, the fossil record doesn't work that way, right? And evolution doesn't work that way. And this is, again, this is based upon their misunderstanding of evolution. That evolution, and this is, in fairness, this was everybody's misconception of evolution 100 years ago. And even today, this is a very common misconception, that evolution is largely linear, right? That you evolve from A to B through intermediary steps. It's like, nope, that is a public misconception of evolution. Evolution is a many-branching bush going in all sorts of different directions. And sometimes we look back with hindsight bias. We say, okay, we're the end result we're interested in, and we look back at where we came from, and you can draw a line to get to us. But our ancestors were not evolving towards us. They were evolving in many different directions. We're just the branch that survived, right? Remember the old display at the New York Natural History Museum? They had a horse display of Eohippus through multiple intermediary steps and then modern Equus. And they had to take it down because it was completely wrong. It was a completely fake sequence. It was not an evolutionary sequence. Horses were evolving all kinds of ways, that branch of animal. And the horses were the one that survived that we're interested in. And then we just sort of shoehorned everything into knowing what the end result was, but with this linear bias. But once you get rid of the linear, you can't understand the fossil record with this linear bias, because that's not the way evolution works. So they say, well, how do we know that actually evolved into people? It's like, well, we don't. And in fact, we probably don't have a single fossil of anything where we know it's exactly in line to be between any 2 points, because they probably aren't, right? Because there were trillions and trillions of individual creatures, and evolution tends to happen in small, isolated populations. And so probably any speciation event you're not going to really catch in the act, right? Everything's a side branch. It's like if you have 7 billion people in the world, what's the probability that you're going to pick out your father as opposed to your cousin? Very little. At random, you're probably going to be picking out distant cousins. That doesn't mean they're not intermediary, right? They're filling in that morphological, temporal, evolutionary space between point A and point B. They're just not necessarily on a straight line, right? So here's the branching bush of human evolution. We're still dickering about which went where, when. And this is how they work. So now this is a creationist quoting Patterson, who was an evolutionary biologist, who said, the reason is that statements about ancestry and descent are not applicable in the fossil record. Is Archaeopteryx, that is a feathered dinosaur, is Archaeopteryx the ancestor of all birds? Perhaps yes, perhaps no. There is no way of answering the question. So he's overstating it a little bit, but he's essentially correct. But then, creationists love to take evolutionary biologists out of context. And so creationism.com says, well, precisely, so why have evolutionist textbooks almost universally and dogmatically declared Archaeopteryx to be an obvious transitional form? Because it is. We now know that Archaeopteryx is not on the line to birds. birds did not descend from Archaeopteryx, but Archaeopteryx is closely related to whatever species did evolve into birds, and it's pretty much halfway in between theropod dinosaurs and modern birds. And so it's a transitional form because it's in there somewhere. It's just not on the direct line. How do we know that? Because we've discovered dozens of fossil feathered dinosaurs, and we've fleshed out this bush so much we know that it's on a side branch now. And there's lots of other side branches that we've discovered as well. And then there are some that are really close to the line that led to birds. Their feathers look right and whatever, their wings look correct. And there are ones that are weird, like Microraptor has 4 wings. They have feathers on their hind legs, cool looking as hell. But they didn't evolve into birds. But are they transitional? Sure they are. It's a feathered dinosaur. It has bird-like features and dinosaur-like features. It's in the middle there somewhere. It's absolutely transitional. There's Archaeopteryx, my favorite individual fossil, the Berlin specimen of Archaeopteryx. It's just beautiful, and those things are feathers, right? Those are feathers. But creationists say, well, how do you know they're feathers? They're just lines in the rock, right? So I'll tell you how we know, but they look like feathers. That's how, because you can microscopically examine them, and they have the microstructure of feathers. But look, there's Paravis. There's a whole branching now descent of feathered dinosaurs. Really, really, and this is such a home run for evolution. Creationists like to say that evolution doesn't make predictions. Well, it does, just not the ones that you want it to. No one could have predicted exactly what evolved into what, but when Darwin wrote Origin of Species, we had none of these fossils. And creationists at the time, they rightfully criticized the minimalist state of the fossil evidence. You have birds, which seem to be their own group, without any obvious connection to any other large group. And Darwin said, well, we're going to have to find things that are fleshing out that middle space. I don't know exactly what the details are, but yes, we will find things. Evolution required that, and that's exactly what we found. I always have to wonder, do creationists get a little queasy when we find stuff like this? I mean, I know their motivated reasoning will take care of it, but I mean, at some level, when you see a beautiful transitional fossil, does it bother them just a little bit? I have to wonder that. But anyway, this is a feathered dinosaur tail captured in amber. So yeah, that's how we know they're actually feathers. Another one is whales, right? So this is, again, the sort of the God of the gaps approach, meaning that always focusing on the evidence we don't have and say that's the disproof or that's what God did, right? But of course, science doesn't know everything. The theories are not correct because they have all the answers. We favor theories that are useful. And what makes a theory useful? Well, it makes predictions about what we're going to find, either observationally or with experiments. And evolution is a phenomenally useful theory, phenomenally useful. For the longest time, we had, again, whales were a group with no connections to non-whales, right? We thought they probably evolved from mammals that walked on land, because what's the other option? But we didn't have any halfway whales. And creationists harped on that. There's no halfway whales. Now there are. In the 1980s, we started discovering, mainly in the Pakistan region, we have a fossil window where we're pulling out all kinds of fossil whales. Ambulocetus, again, that's the middle one. That's the one that's pretty much half whale. It's a whale with legs. Come on, it's a whale with legs. It's totally half whale, half terrestrial mammal. It is a perfect transitional fossil. So this is Kirk Cameron, who had a short-lived career as a TV star and then a later career as a creationist, working with a Australian creationist. I'm forgetting his name. Somebody will shout it out. But anyway, it'll come to me. But he calls this the crocoduck, right? It's like a duck with a crocodile head. His argument is, if evolution were true, then the fossil record should be full of these sort of hybrid animals that are halfway from turning from one type of animal into another type of animal. But because we don't find crocoducks in the fossil record, evolution isn't true. So yeah, there's no transitional fossils like a crocoduck because nobody believes that there should be, and that's not how evolution works, right? There's no horizontal evolution from one group to another group. You always evolve into derivative types of stuff. If we killed all of the animals in the world except for dogs, dogs would evolve over the next 1,000,000 or 10 million years to fill all of the niches left behind, but they would all be dogs, right? They wouldn't evolve into giraffes. and bears, and lions. They would evolve into dog-like versions of those things, right? The evolution doesn't go backwards or horizontally. It's always evolving forward. Anyway, creationists misunderstand evolution, and their criticism of evolution is derived from their own ignorance of evolutionary theory. Okay. Michael Egnor is a neurosurgeon, creationist, who blogs for the Discovery Institute, which is an organization that promotes intelligent design. And he and I have been foes for the last 10 or 15 years. Friendly online, repartee, but he frequently appears in the comments of my blog to push back against what I'm saying. And so I chose one that I thought was especially enlightening. And he writes, but evolution, novella means Darwinism, they love to make it that culture war, right? It's about the guy, it's not about this 200-year-old theory. Predicted none of this. I challenge Novella to cite references from evolutionary biologists during the past 150 years predicting that birds, rather than reptiles, would be found to be related to dinosaurs based on Darwinian principle of heritable valuation and natural selection and common descent. So what's he doing there? First of all, he's completely muddying his argument. I don't even know really what he's talking about here because it doesn't make any sense. But because dinosaurs did not evolve, or birds did not. He says that birds would evolve from dinosaurs rather than reptiles. Well, dinosaurs are reptiles, so it doesn't really make sense that way. What he's trying to say, I think, is that birds evolved from dinosaurs rather than other kinds of reptiles. And that was the competing theory 100 years ago, 150 years ago. We knew that birds probably evolved from reptiles because that's the group they're the most similar to. But there was did they evolve from the branch of dinosaurs, or did they evolve from reptiles that were lizards or reptiles that were crocodiles? That was not known, and there were competing theories based upon their lungs and the other type, whatever. With the little information we had, we were trying to fill in all the missing pieces. But it's 150 years later. We've discovered many, many, many fossils. Now we have, again, so many feathered dinosaurs. It's absolutely clear that birds evolved from dinosaurs. But what he's saying is, but evolutionary theory didn't predict that would be the outcome. You're right, it didn't. Because there's nothing in evolutionary theory that you can use to predict exactly what evolved from what. That's not how it works, right? It's like saying that, well, you can't tell me what the weather is going to be like a year from now, therefore climate science is all wrong. No, climate science does not predict the weather, right? That makes sense? Climate science describes what happens over long periods of time. It's trends in the weather. It's not what happens on a specific day. That's chaos. The outcome of millions of species evolving over hundreds of millions of years with trillions and trillions of individuals, no, you can't. It's inherently unpredictable. And evolution doesn't pretend to make those predictions. But all we do predict is that something evolved into birds. And we will find something in between birds and another major group, and we did. But again, this is a way of moving the goalpost, right? Setting a standard that you can't meet. Because again, your goal is to cast doubt on evolutionary theory, so you make impossible demands for evidence. All right, here's another one. Sorry about all the words, but I want to give you the actual quotes from creationists so you know I'm not just making it up, right? So mutations. Creationists love mutations, but they really, really don't understand what they are and how they work. Mutations are commonly associated with disease, not upward evolutionary improvement. A closer analysis of this new study shows that its evolutionary conclusions are deeply flawed and humans are actually devolving. This is exactly what modern biochemical data shows, and the Bible indicates is happening due to the effects of the fall, where the whole creation is subject to corruption. So, multiple misconceptions in here. Again, their criticism is based upon their own misunderstanding of evolution, which is based upon creationist, religious worldview. So, first of all, mutations are not inherently associated with disease, right? Every gene is mutated. We are all mutants. Every single one of your genes is mutated. Mutation is a natural part of life, and over the last, 3 or whatever plus billion years, genes have been mutating. They mutate all the time. there are different degrees to which genes mutate. I mean, all genes are mutating pretty much at the same rate. The question is, how conserved are the states of the genes? There are some genes that are so critical to life that any mutation and you're dead, right? So you don't see them because those are spontaneous abortions, right? And then there are other ones that they will tolerate a lot of mutations. And for those genes, there's pretty much a genetic clock where they're mutating at a regular basis. But their starting point is that life started in some perfect form, and any change can only be devolution, right? It could only be going farther and farther away from some inherently perfect form. But there's no such thing, right? There's no such thing as a perfect form in biology. It's all a mess, right? When you study biology, you realize it's all just a hopeless mess that just somehow works, right? It's a kludge. Biology is a kludge. So it just works well enough, that's how biology, and that's because it's a bottom-up evolved system, right? It's incredibly, elegant and beautiful, but that's because that's how evolution works. But it's not. But any state is equally valid to any other state, right? The other thing sort of related to this is this notion that evolution is this inherently upward improving process. No, it isn't. Evolution is no inherent progress in science, in evolution. Do you know who figured that out? Actually, the first evolutionary scientist to figure that out, it actually wasn't Darwin. It was Lamarck. Lamarck gets a totally bad rap, by the way, historically. Whatever you think you know about Lamarck is wrong. He didn't come up with the idea of the survival of inheriting acquired characteristics. That wasn't his theory. That was just the prevailing theory before Darwin. Lamarck didn't particularly champion it more than anybody else. What Lamarck did, though, was he spent his lifetime studying the fossil record as it had existed. He started with this bias that evolution is an inherently progressive upward change over time. And what he found was that wasn't the case, that it was all horizontal, just adapting to local environments. Any movement in any direction was just an epiphenomenon because it's moving in all directions, right? Stephen Jay Gould writes very elegantly about this, by the way, who's a more modern evolutionary scientist. It's like evolution's not progressive, it's not upward. Bacteria have just as much evolutionary history behind them as you do. You're not inherently more evolved than bacteria. They're not more primitive. They're just different. They just evolved differently. That's it. Evolution just adapts to the local environment. So everything's a mutation that's just locally adapting. There's no progress. So the fact that we don't see progress is not a problem. Mutations are fine. Now, some are harmful. Some are beneficial. But what's harmful and beneficial? It's not because you're more or less pristine or in some perfect predetermined form. It's just what works well for you right now in your local environment. Some variations may be beneficial in some contexts, harmful in other contexts, and honestly, most are trade-offs. Most have some benefits and some harms, and if the trade-off is net positive, you're more likely to survive. If it's net negative, you're a little bit less likely to survive. And most mutations are neutral. They do nothing. Most by design, actually. The genes are evolved to tolerate a lot of mutations, so most mutations don't change much, with the expression of the gene or the protein. So it's just wrong. So these are all just creationist concepts grafted inappropriately onto evolutionary theory. So, right, devolution is not a scientific term. They made that up. There's no such thing. All evolution is evolution. There is no evolution and devolution. It's completely made up. I went over all this already. So one thing that creationists say is that, mutations only degrade information. It doesn't add information. It's like, no, mutations just change information. They don't degrade it. And they absolutely can increase the amount of information, which is required for evolution, because if you start out with a very simple organism and you end up with some organisms having many, many more genes, you had to add genes over evolutionary time, at least in some lineages. Not necessarily inherently, but just sometimes that had to have happened. Here's one way we know that happened. It's called gene duplication. When a cell splits or divides, sometimes one gene gets copied twice. And now you have two copies of that gene. What happens? Well, initially, both genes are doing the same thing, but they're going to mutate randomly in different directions. And that's okay. Now that you can tolerate those mutations more. If one of those genes mutates in a way that it's no longer doing what it originally did, that's okay, because you got another copy who's still doing that, right? It's still making the protein that you need. So now you have two copies of a gene, and they can evolve in different directions, and that's what happens. So we've actually been able to reconstruct the evolutionary tree of individual genes. Just like there's an evolutionary tree of species, there's an evolutionary tree of genes. We know that that protein evolved from this protein. They have a common ancestor over here. And so that we could see the increase in genetic information over time in different lineages. So it's, again, factually incorrect. Okay. So who here knows what epigenetics is? Yeah, very, very few people. That's why creationists like to talk about it, because most people, unless you study biology, I know a lot of the biologists raise their hand, thank you, they don't really know what it is. But basically, it's not that complicated a concept. It's basically things that affect the expression of genes other than the genes themselves, right? It's epigenetics. It's not the genes. It's things that influence the expression of those genes. Because that's really, really important. It's not, go back 100 years, we thought that, the gene is the thing, right? The morphology, is entirely determined by the sequence of amino acids in the genes. Like, okay, not quite. That's critically important, but just as important is all the extra genetic material, the stuff that's not in the gene itself, that is determining how many copies of the protein are made from that gene, right? How active is that gene? When does it get expressed? How much does it get expressed? That could have a profound effect. When you think about it, your heart cells and your brain cells have the same genes, but they're very different. They're different entirely because of which genes get turned on and off, when, and how they're expressed, right? Same thing happens between different species. You can have they can have similar genes, but they're expressed very differently. Those expressions are epigenetics. They're affected by other things going on in the cell. In the last 20 years or so, scientists have discovered that these epigenetic factors can be inherited. Say, the inheritance of non-genetic material, that falsifies evolution. No, it doesn't. First of all, epigenetics, as far as we can tell, it lasts 1, maybe 2 generations, right? So these are factors that, like for example, a mother in the egg that a mother passes to her children, there's other things in the cell other than the DNA, right? And those other things can influence how their children express those genes. And so it's very interesting adaptation. If a female gives birth during a time of famine, her children are a little pre-adapted to famine because they're sort of biochemically ready to thrive in its period of less availability of food because of those epigenetic factors that got carried down. So this is really a tweak on inheritance and evolution. Doesn't have anything to do with evolutionary theory itself, but creationists like to pretend that it somehow falsifies evolution. I'm going to skip over that one. This is the last point I'll make, and then I'll take some questions. So another sort of logical bait and switch that the creationists pull is they say that design implies, this is intelligent design, right, to a T. Design implies a designer. Therefore, if we could see evidence of design in life, it had to have been created by something intelligent, right? That's the whole point of intelligent design. But they're kind of assuming their conclusion, right, which you're not allowed to do in logic or in science. They're assuming that anything designed was designed intelligently. So they're kind of assuming that there's no such thing as something that any kind of design that could emerge through natural processes, right? So if you kind of assume that you win at the beginning, yes, of course, then you're going to win at the end. So then all they have to do is say, look at this exquisite design in biology, and therefore intelligent designer. But they're ignoring the actual argument, right? The actual debate, if you will, it's not really a debate that scientists have, but the actual conflict is between, everyone acknowledges there's design. No scientist or evolutionary biologist says there's no design in nature. The question is, does it look as if it was designed from the top down by an intelligence, or does it look like something that was designed from the bottom up through natural chaotic processes? Well, how do you know, right? How would we know? It's like, well, if a process evolved, right, if the design emerged as a process of evolution, we would expect the history of that process to be left in things that are around today. So like with genetics, we could look at the relationship between the specific sequences and see, does my sequence of amino acids, have more in common with a chimpanzee than a horse, right? Our hemoglobins are identical pretty much, but you can have identical hemoglobin, that molecule could be identical, but the exact sequence of amino acid could be different because multiple different sequences can result in the same amino acids. So there's absolutely no reason why the molecular genetics, right, the sequencing of those amino acids should fall into a nestled hierarchy of relatedness unless things are actually related. And in fact, they do. You could pick any protein, any gene, and then compare them among different groups. And the closer two groups are evolutionarily, the closer their gene sequences are, even in ways that have no implication on the actual protein, right? Silent changes or silent mutations. There is no explanation for that other than an evolutionary common descent. That's what evolution predicts, right? What does a top-down intelligent design predict? There's the rub, right? I said at the beginning of my talk that intelligent design is not a science because it's not falsifiable. Now, I think that if the intelligent design proponents were intellectually honest, they would say that, well, there would probably be a random pattern or a non-evolutionary pattern, because of all the patterns that we could find, only one really fits into an evolutionary pattern. And the chances of that occurring by chance alone is infinitesimal. It's basically zero. So chances are it's going to be something other than an evolutionary pattern of relationship among genes for different proteins. Right? And again, you can go look at thousands of proteins. They all fall into an evolutionary pattern. So it looks like bottom-up evolution, right? What do they say? Well, maybe God just decided to make it look that way. It's like, yeah, you're right. Maybe God did. The intelligent designer. You're not supposed to say God. The intelligent designer just happened to make it look that way. That's why it's not falsifiable, right? That is exactly why intelligent design is not falsifiable. Because no matter what life looks like, the intelligent designer just arbitrarily decided to have it look that way. And for whatever reason, he wanted it to look exactly like it evolved. But again, the scientists say, well, yeah, it does look exactly like it evolved, and that's the end of the story, right? That's the end of the scientific story. Okay. Here's a couple other favorite examples. The panda's thumb, right? Pandas evolved from carnivores. Carnivores, they're carnivora, that group, the carnivora, their fingers all go forward as claws. And then panda bears then became herbivorous. They eat bamboo shoots. So they don't need claws anymore. They need something that could strip bamboo, shoots off of a bamboo. They needed a thumb, but they lost their thumb because their ancestors were carnivores. So what did they do? They didn't go backwards, because you can't really evolve backwards. They didn't make a thumb out of whole cloth, right? I would think the intelligent designer would have just given them a thumb, right? But what they did was one of their wrist bones expanded and became kind of a clumsy sort of thumb that works well enough so they don't starve, right? So it looks kind of like it evolved from whatever materials were available at the time, morphologically, anatomically. Not something that was designed from the top down. But, who am I to to second guess the intelligent designer, right? I'm not. That's why it's not falsifiable, right? No matter what we see, that's just what they wanted to have happen. I actually wrote an article in the peer-reviewed literature on the anatomy of the eye, right? Specifically focusing on those details that are pretty good evidence of the quirky sloppiness of bottom-up design, right? The big one is that in vertebrate eyes, the light-sensing layer of cells are at the bottom, right? All the non-light-sensing cells are on top of it. So the photons have to go through the blood vessels and through all the other cell layers, and then they hit the photoreceptors. Why? Because that's just how it happened to evolve, right? Because of decisions that were evolutionary choices that were made before the eye fully formed, fully evolved, and we kind of, evolution, you can't go backwards, so you kind of get stuck with the choices that are made, and you have to just do variations on a theme. So that, then there had to be a lot of hacks. You had to sort of move the fovea out to, where the blood vessels come in out to one side, and you still have a blind spot, but, we kind of compensate for that by the brain does some trickery to make sure you don't see the blind spot and everything. But that's all just a hack to fix the fact that the basic design is backwards, right, of the eye. So what do creationists say? Well, maybe that design works for some reason. It's like, well, okay, then, but in cephalopods, like the octopus, their eye is the right side way around. Why? Because they evolved an eye completely independently from vertebrates, and it was a coin flip, and their eyes came out one way, and vertebrate eyes came out the other way. But there's no, you can't say that one design is inherently, like that the backwards design is inherently superior, because the designer didn't choose it for everybody, right? Only chose it for some branches of life. You also don't see, not for nothing. It's not like an octopus has one kind of eye and a squid has a completely different eye. We never see that in biology because, again, it always follows this nestled hierarchy of common descent, a pattern that is required by evolution that's not required by a top-down, everything according to its kind designer, right? Okay. Last slide, then I'll stop for questions. So irreducible complexity, this is Michael Behe's thing, and it basically says that if you have something which couldn't function in its current form, to its current purpose, if it were any simpler, well then it's impossible that involved. Again, he's trying to get to that impossible. That's like the holy grail for creationism. It's like, okay, so his example is the bacterial flagella, which is a fairly complicated little molecular machine. It's the tail of like a bacterium that spins around and propels the bacteria through water, which at that scale is very viscous, right? So, well, you can't take any of the pieces out of a bacterial flagella and have it still work as a flagella. So how did it evolve into that state? Well, interestingly, Darwin himself had an answer to this question. This came up, even in Darwin's lifetime, and he answered it in The Origin of Species. He spent a long time answering this question, and very quickly, the answer is because it evolved from something that worked, just not as a flagellum, right? So what's good is half a wing? Okay, a half a wing is no good for flying, but it could be good for a dozen other things. And it's, again, a half a wing is not evolving towards a wing. It's a perfect something else that just happens to have been incorporated by some branches of things with the, it's not a half wing, right? It's something else. So we actually have feathered dinosaurs with half wings, but it's only a half wing if you're looking at it from the hindsight bias of knowing that that's one of those branches are going to evolve into birds, right? But we have feathered theropods who were using them for something else, right? They were using them for thermoregulation. They were using them to trap prey, maybe to increase the distance of their predatory leaps, or to maybe at some point to glide, and then maybe they would climb up a tree and then jump down on their prey, and it helped them control, whatever. There's all kinds of things that they could have done short of flying. And one of those branches or more, evolved full flight from that. But they're not half wings. They're a full something else. So the flagellum evolved from something that wasn't half a flagella. It was a full something else, right? And since Behe wrote that, we discovered what it was. Again, this is the beautiful thing. It turns out that the type 3, I think, secretory molecule is a primitive, relatively speaking, flagellum. Clearly, the flagella clearly evolved from it because it has like 80% of the pieces that the flagella has, but in a slightly different arrangement, and it's not a flagellum, it just injects stuff into other cells, right? It just secretes, something. So the evolution can find stepping stones, to go from A to B to C to D. It didn't have to evolve straight to D. And Darwin kind of worked this all out 150 years ago. He was a pretty smart guy. He spent a lot of time thinking about how we can get natural selection and evolution working. And that's why it took him so long to finally publish, what he called his one long argument. And so I just want to end with that thought that, it occurred to me that, I think that one of the measures of the impact that your life's work had on the world is that 150 years after your death, people are still arguing against you. Think about it. Every creation, it's Darwinism, it's Darwin's black box, why Darwin was wrong. It's all Darwin, Darwin, Darwin. And of course, on the scientific side, we respect Darwin for his massive contribution to a very important scientific theory. But we also recognize that the science of evolutionary theory didn't stop with Darwin. It's not Darwinism, it's modern evolutionary theory, which has progressed quite a bit in the last 150 years, thank you. But it is based on a very solid foundation that was provided for us by Charles Darwin. So again, thank you very much. I very enjoyed being here. I'm happy to take any questions. Yeah. Are you going to pass a microphone around, or should I just repeat the question?
Just repeat the question.
Yeah. So the question is, do I have any personal religious beliefs, and do I see any value in understanding religion to a scientist? So my personal history is I was raised Catholic. I was a full believer until my late 20s. I sort of went through a process of becoming agnostic, sometime in my 20s. I fully accepted evolutionary theory when I was younger. It was not incompatible with my religious beliefs at all. In fact, most people happily have religious beliefs and accept scientific, evolution and other theories. It's really only some religions that choose to make it a war between the two. I personally think that I actually studied theology through high school. I went to a Catholic prep school, required course. I had to take theology every year. I think it helps me a lot, actually. At this point in my career as a science communicator, I have a much easier time wrapping my head around how people who believe in something ideological, doesn't have to be religious, think, because because of my upbringing, because of that history. And a lot of my colleagues who were sort of raised atheists and never had any religious belief, they do have a harder time sort of understanding how the mind of a believer works. So I do think it gives me a little bit of an advantage. Yeah. So do I believe in prayer is the question. My question then is, well, what do you mean by that? Do I believe that prayer does what, right? So if the question is, do people feel better when they pray? Does it have some psychological utility to it? Does it have a community benefit to it? So the evidence is pretty clear that people who are a member of an organized religion, an organized belief system, it could be a non-religious belief system, have multiple advantages. They live longer, they weather illness and adversity better. So people do better when they have a social support structure, and a lot of organized belief systems like religions do provide that with clear-cut advantages. Do I believe that intercessory prayer has a real-world effect independent of that? So and there's a literature to that. There's been a number of studies asking that very specific question. So in other words, praying for somebody who doesn't know they're being prayed for, right? Does that have a demonstrable scientific effect? And I think the very clear answer is no. First of all, there's no reason why we would think that it does. But despite that, it's been studied, and to the extent that it has been, the answer so far is no. There's no measurable effect. Now there's, of course, like in every complex medical, clinical trial, there's going to be a range of results, and you have to look at the totality of the research. And so some studies show small effects, but they're never the same effect. So when they're not you can't replicate them. So basically what that means is that they're just random effects, and then the next study shows different random effects, and the next study shows different random effects, but no effect replicates from study to study, which means there's no real effect there. It's just all statistical noise. So that's what the evidence shows. So does that answer your question?
Okay.
Okay.
I guess for
Mm-hmm.
In the communication aspect that you're doing something and you're putting out a request, because if you take a bird in flight, it runs into a thunderstorm, it's in need. And in that need, it has to adapt. That adaptation is a request. It's unheard or unseen, but it causes an adaptation and change in some of that. So when I ask you from that perspective.
So yeah, and that it would be the theological evolution position. So that evolution happened, right? You look at the biological world; it's pretty clear. Common descent is kind of a home run, and there are those people who accept that. They say, "Yep, evolution happened, no question." But I just think God was the one pushing it forward, and which is, of course, then that's a more sophisticated sort of argument to make. So all I would say, that becomes the unfalsifiable hypothesis. If you want to believe that the hand of God is behind the natural world, you're free to do so. But science cannot operate that way because it literally cannot function with supernatural hypotheses because they're not falsifiable, right? How could I disprove that that happened because God wanted it to? You can't. How can I? And the classic example of that is maybe God made the world 10 minutes ago, but to look exactly as if it evolved over 13.5 billion years, right? That could be true. I can't prove that that's not true. It's framed to be unfalsifiable. So if your belief is framed in such a way that it's unfalsifiable, that's fine. I have no problem with that. It's just not science, and it doesn't influence how we conduct science. So if you want to frame it as a scientific question, is there evidence for any forces at work in evolutionary history as we're able to describe it that is beyond the realm of natural forces? The answer is no. We haven't detected any. There's no need to hypothesize anything beyond the mechanisms that we know to be at work in evolution. And so we can understand evolution naturalistically. We don't have to appeal to anything supernatural. But if you want to believe that there's a supernatural meaning to things, that's outside the realm of science, and I have no problem with that. As long as you keep it separate from the process of science, which can't function. They're incompatible because science requires things to be falsifiable. Yeah. So, do I think that the evolutionary deniers lack critical thinking? So, I mean, the short answer is yes, only because I think everyone lacks critical thinking, right? Critical thinking is hard. It takes a lot of work. It takes a lot of study. That's like saying, do you think people lack a sophisticated understanding of philosophy? Yeah, unless you're a philosopher, right? Nobody, unless you've studied philosophy. So, critical thinking is not something that comes naturally to people. And this, again, psychologists have been documenting this exquisitely and in great detail and increasing detail over the last 100 years. People are not inherent critical thinkers. People evolved to follow certain heuristics, which is basically our sort of naive, intuitive type of thinking. And it kind of gets us through the day, right? It sort of works most of the time, and it has the advantage of being very quick, very down and dirty. And that quickness apparently was more of an adaptive benefit than the long, slow drudgery of like carefully thinking logically and analytically, right? Actually, in reality, we do both, right? We have intuitive thinking and we have analytical thinking, and we mostly do intuitive thinking, but we can do analytical thinking when we need to if you know how to do it. But the critical thinking is like really at the extreme end of the analytical thinking spectrum, and no, people are don't inherently function that way. It's a learned knowledge base and skill. I don't think creationists are any different than anybody else, in terms of that. And if you study them, they're not. They're just people. So people are not critical thinkers. But what is different is that they are embedded in an ecosystem of a belief system. And this one, because it became a political issue, and really not until it became a political issue, so around the turn of the century, about 30 years or so after Darwin, it became a political issue in this country. And when that happened, there developed, I dare say evolved, right, a system of essentially a culture of evolution denial that has itself been developing over the last 100 years. And it's pretty pervasive in certain subcultures, and it's pretty sophisticated. There are institutions. It's institutionalized denialism. The Discovery Institute is an institute of evolution denial, right? They're politically powerful. They have a lot of influence. They have their own literature. They certainly have a massive presence in social media. That's the difference. They're just as critical thinking as anybody else, which is not very, but they're swimming in an ecosystem of specific, crafted misinformation. And that's hard to get out of, especially when that misinformation is telling you exactly what you want to hear and resonates with your tribe and your identity and what you want to believe. It's really hard to break out of that. Yep.
What is the most fascinating thing you discovered about practicing neurology and stuff with evolution?
The most fascinating thing I encountered with evolution in my practice as a neurologist. So I think the thing that I encounter where evolution informs my thinking is when we are treating the brain. And a lot of how we treat the brain deals with the different parts of the brain and how they function. And anytime we prescribe a medication for brain function, we're dealing with the inherent limits of evolution. And this gets back to what I was talking about, the gene duplication. So for example, the brain largely communicates, like brain cells communicate with other brain cells through what we call neurotransmitters, right? These are chemicals that give a chemical signal from one cell to the next. And so if I want to alter brain function, right, to treat some neurological disease or disorder, a lot of the times those medications alter the function of those neurotransmitters. They either increase one particular neurotransmitter or decrease another one. But those always have interesting side effects. And the reason they do is because the brain wasn't designed from the top up. It evolved from the bottom up, from the top down. It evolved from the bottom up. So neurotransmitters are all related to other neurotransmitters. And their distribution in the brain is not discrete. So if I want to block dopamine in the basal ganglia, I'm also blocking dopamine in the frontal lobe, which has a completely different function, and I don't want to do that, but I can't help it because those receptors are evolutionarily related to each other. They're different enough that the brain functions, but they're not so different that I can target one and not the other with a drug. So evolution is an inherent limit on the effectiveness and specificity of neuropharmacology, and I deal with that every single day in my practice. Yep.
Me?
Yep.
As I told you the other night, biology is not my area of expertise. But you were saying that we're all mutations. And when I first read about mutations many years ago, I was under the impression that they were rare, random chance occurrences, like the Earth colliding with a comet. And is what you're saying, if I understand you right, is that mutations are actually far more common and far more frequent than what I had thought?
Yeah, that's correct. So you used to think that mutations were rare and isolated, and what I'm saying is that they're common. Yes, every single person here has multiple mutations. In fact, on average, you probably have the genetic mutations for 7 horrible genetic diseases, but they're recessive, and so they don't express themselves. That's just on average. And just you hope by random chance your horrible mutations don't line up with your spouse's horrible mutations, and they usually don't because there's a lot of them out there, and you have some 7 random ones and she has 5 or 6 other random ones or whatever. But that's why we don't want cousins to have kids because they're more likely to have the same ones, right? The same mutations. But yes, everyone is born with their own mutations. Right? No one is born without any mutations, or it's so far at the tail end, it's like basically doesn't exist. Does that make sense? So yeah, that's why we're all mutants. We are all mutants, and again, none of our, no one is more mutated than anyone else, right? It's the only difference is the effect of those mutations. Most mutations are silent, most are benign, most are trade-offs. It's not necessarily a net positive or negative. It's like, yeah, you have some strengths and weaknesses. It's just variation. It's all just variation. Let's go over there. I'm sorry, can you speak up a little bit?
Why do you think creationists are, some of them are threatened by evolution? What is their containment if you wake up one day and it's a mutual consensus that evolution didn't happen?
Mm-hmm. So what do creationists, why do they feel threatened by evolutionary theory? Is that basically the question? So I don't know. I try not to get too much inside it, people's heads and read their minds. I sort of go by what they say and what they do. But what I suspect is, this is not just limited to creationists, but I think, and what the psychology shows in general, again, but it's as my talk last night kind of implied, every topic is a little bit different, but one common theme is that it's the implications of the science, what they think are the implications of the science, what they're being told are the implications, right? So they're being told that if you believe in evolution, you're an atheist, which means you're immoral, which is not true, right? And you're going to destroy America, right? You're going to destroy society with your immorality. And so believing in evolution is akin to destroying the fabric of our society. It's not about the science, it's about the culture war, right? That's what they're told. And that's what is believed by everyone that surrounds them, right? If that is embedded in your tribe and it's just sort of taken for granted, we tend to believe those things and not question them. If you grew up in certain parts of the country, that's just part of the background fabric of your worldview. And interestingly, I always find this amusing. I was surprised when I first learned that a lot of fundamentalists think that atheists are Satanists, right? Which, of course, as an atheist, is like, really? That's like a complete opposite of what an atheist is. But that's just sort of, those two things get conflated. Like the first time I had somebody say, well, so do you believe in Satan? It's like, no, I just said I'm an atheist. I don't believe in anything supernatural. I'm actually agnostic, right? Any supernatural idea is unknowable inherently, and so I choose not to have an arbitrary belief about an inherently unknowable hypothesis, right? That's an agnostic. But to them, it's like, you're a Satanist. Because it's like if you either believe in God or you're a Satanist, so everything else gets lumped into sort of the same bucket. So that's kind of what we're dealing with. There's a lot of propaganda, a lot of misinformation, but it's all politically serving this culture war, which is really the thing. It's not about the science. They're not threatened by the science. They're threatened by what they think are the implications of it. Yep.
One thing I was wondering is how you would respond to someone who would say that evolution provides us with a reason to doubt our rational faculties that we use to demonstrate evolution, given that adaptive behaviors can be motivated by false beliefs.
So, if I'm understanding the question is, so the evolution falsifies itself in a way that, if we evolved faculties that would cause us to doubt rational thought itself. So, my answer to that is that humans are multifaceted. We have capacity for irrationality, for emotion, for bias. We also have the capacity for reason and logic and philosophy. And we hit upon this thing called science, which is a set of methods that help us sort of rise above all of that irrationality and bias and everything, and to try to get closer and closer and closer to some kind of a objective empirical description of the world that we live in, to be at least less wrong, as some people put it. So that's my answer to that. We're not just one thing. People are sort of multifaceted, and we can be irrational and we can be scientific at the same time. In fact, most of us are. I'll come over to the side. One more question. Yep. Yep.
So I know that you kind of talked about it. It's just I don't guess I caught on. But I understand and I get that all of us are made out of mutations. And, that's what every gene is that we have. But why are the bad ones talked about more than the ones that actually help us and make us a better species?
So why are bad mutations talked about more than good mutations? I think it depends on what world you're swimming in, right? What are you talking about? So among biologists, I find that it's equal. In fact, I was reading recently about we often use the term variant, it's not just a mutation, it's a variant. It's a better term. There are variants that are associated with being protected from certain diseases or responding better to certain medications. There's a variant in 2 different proteins which are associated with greater intelligence, and that those variants are actually increasing in frequency over time in the population. Doctors talk a lot about mutations that cause disease because we're interested in understanding the cause of diseases, right? And so silent mutations are non-events. If you have a mutation that doesn't do anything, there's not much to talk about. If you have a disease that I can explain that disease based upon the effect of a mutation on a certain protein and then understand how that altered protein has different biochemistry and how that results in whatever it is we're talking about. So we talk about that a lot. But I think that in the media, they have this equation of mutation with disease. And so that's partly just an artifact of journalistic jargon, but it doesn't really reflect scientific reality. And then I think the other aspect of it is like the movies, right? Like the X-Men are mutants, And so mutants are sort of associated with being something completely different, when in fact, again, we're all mutants. There's everything is a variation, right? Everything is a variation. What we actually mean by a mutant is that we can detect that there was a change, at least a one amino acid change from a previous state. That's it. But again, that wasn't a pristine state because that state was also altered from some. It's all just variation. It's really a relative term. We notice there was a change at some point. Where this an A became a G or whatever in the genetic code. All right, thank you guys. I'm sorry. I'll stay after if you have other questions.